Okay, so if you're watching part 2 to this video, you are getting ready to experience the wonderful opportunity that Mettler Toledo MP-50 system can provide you. You will love it so much, especially after you go through the horrible ordeal of doing the melting point by hand, not once, but twice. Oh yeah, you can see the excitement that I have for melting point already, can't you? So, very early on, back into the 1960s, or even earlier before that, we get an instrument in the laboratory called the Fisher-Johns melting point system. So, Fisher-Johns melting point system, and I'm just going to abbreviate that with an MPS. And here it is. Isn't she a beauty? Fisher-Johns apparatus. So if you go to Wikipedia and you type in melting point apparatus, the Fisher-Johns is the very first one that comes up. And it says, a melting point apparatus is a scientific instrument used to determine the melting point of a substance. Some types of melting point apparatuses include the field tube. Oh, that looks familiar. We talked about the field tube already. You've done that by hand already. The Fisher-Johns apparatus, the Gallenkamp, or electronic melting point apparatus, and an automated melting point apparatus. So the Fisher-Johns was one of the first. And what happened here is that with this instrument, there's a small magnifying glass that's right here. You can kind of see that in the picture if you look really close. And this magnifying glass kind of turned back and forth. It was kind of on a spindle, so you can move it out of the way, and then that would allow you to load your crystals. And your crystals would go right here on this aluminum kind of pan. So we would take a scoop of crystal, we would dab a little bit of it down here at the bottom on a slide, kind of like a microscope slide in a way. And then, just so that we could see those crystals melt a little bit better, this magnifying glass could switch over to the top, and we could kind of look down from above through the magnifying glass and kind of peer at these crystals. And wait. And wait. And wait, and wait. And if you didn't have a back cramp by the time that was done, and if your eyes didn't strain by the time that was over, well, you were lucky. So consider yourselves a melting point apparatus pro, because that's what was going on. So we wanted a better way to do this. Now, where does the heating come from? So the heating, there would be a lamp. The lamp would kind of shine down onto the crystals. The crystals, or this chamber, would heat up. A thermometer would be right here. So this is your thermometer point. And that thermometer would record the temperature or the melting point at which the crystals melt. But it was based on you. It was very subjective. And this is bad news for a laboratory. We do not want it subjective. We want the same number every single time. So if I go on down this page, you're actually going to see the field tube picture that's presented here. And this is something that we talked about in the last video. So they are calling the field tube a melting point apparatus. Now notice the careful word, apparatus, not instrument. Right? We want apparatus. Okay, so what other things are out there besides the Fisher-Johns apparatus? Do I have something else that's maybe a little bit more updated? And the answer is, of course, we do. So what we now have is a Mettler Toledo melting point system. Now, Mettler Toledo is going to be a name that you're going to hear very often in the chemical analysis world. Mettler Toledo is a leader in some of our balances and some of our common instrumentation, like the melting point system that we would see in a laboratory. The next time you go to Walmart, go up to the deli counter, ask them to cut you some cheese or some meat. Take a look at the balance. that they use to weigh out that material. You're going to see probably Mettler Toledo stamped onto the side. So it even takes its place outside of the laboratory environment, and it goes into places like that. That's just what I would call run-of-the-mill, everyday type of setting that these balances and some of this equipment is being used. So take a look. Start paying attention to the instrumentation manufacturer of these instruments when you go out, even to Walmart, and look again at their deli counter. Prove me out to be a liar. So the melting point system is called the MP-50, and it's basically an automated version of what you do by hand. So if you notice, it says, hey, we get a one-click melting point. We have a touch screen. We also video record, and we play back all on the instrument. So what's so special about the instrument? Well, first off, I think very much of your education, right? I want you to excel, and I want you to succeed. So because of that, I'm going to invest in your future. Well, how much did I invest into your future? A whopping $6,000 for this instrument. So $6,000 this instrument cost the program to implement it in our lab. But we use it so often, and we use it so much. And if you're working in a pharmaceutical environment, these are the types of things that they will have in their working laboratory. So $6,000 to do a melting point for you automatically. So what happens is that, remember that capillary tube? You still need to pack the capillary tube. So number one, we're going to have a capillary tube. And you're going to pack it just like you did before. And for some of you, that was horrible. For some of you, you can't stand packing that capillary tube. So if you're watching this video and you've already packed a capillary tube before, you're going to understand what I'm talking about. Capillary tube and to pack a tube is probably one of the most difficult things about this whole analysis, both by hand and by instrumentation. So there's not really a right way to pack a capillary tube. They sell this fancy little tool that we can use for the melting point system that will help you pack the capillaries, but we don't need that. I'm going to make you suffer. So I'm already letting you get away with putting it on the instrument to do it. I want you to work a little bit for it, break up a sweat a little bit, use that elbow grease in the lab for a purpose. So I'm going to make you pack that capillary tube as is. So pack the capillary tube. This machine can actually pack 4 capillary tubes at one time. So that means up here at the very top, once you go in and see this instrument, you will see 4 slots up here at the very top that can hold a capillary tube for you. Now, you don't have to do all 4 at once. You're only going to really do 2 samples, and that's it. So do 2 of them at one time. So take 2 capillaries, pack both of them, load both of them up into the instrument, and you are ready to go. So we want you to do it twice. We like to do things more than once. Remember, 1 time is luck, 2 times is coincidence, 3 times and we'll talk. All right, so once you load these capillary tubes up into the melting point, you're then going to touch the screen and you're going to tell the melting point system to begin. Now, the problem here is that where do we tell the machine to begin? So here I'm going to write a big question. Where do we start? So if you take a look at the chart that we have provided in the lab, you're going to see that the lowest melting point that you should be seeing is around 48 degrees. And you're seeing that the highest melting point is going to be around 148 degrees. So where do we make this machine stop and where do we make this machine end? Well, the choices that I have to choose from will help me determine that. So that means in the setting on the instrument itself, it's going to ask a start value and an end value. We are going to put 45 and then we're going to put 155. So we go a little bit below and we go a little bit above on the actual setting itself. And this machine does register in degrees Celsius. It's not degrees Fahrenheit and it's not Kelvin. It is the Celsius temperature that we're reading from. So these are how I determine my start and end temperatures, and this lab tells me the choices that I have to choose from gets me in the range of 45 to 155. Then you're going to see a very important one called rate. And right now, by default, the rate is set at 10 degrees for every minute. Okay, now here's the issue that I have with the rate. The wider the window, the longer you're going to have to wait for your stuff to melt. Because this means that for every 1 minute, you're going to see a 10-degree difference. So that means at 45 degrees, if that's where I start, 1 minute later, it will be 55. Another minute later, it will be 65. Another minute later, it will be 75. Another minute later, it will be 85. So if it's not going to stop the analysis until 155, well, look at it. 155 minus 45 is going to be 105. And then it's going to convert 10 degrees every minute. So this means it's going to be a 10-minute runtime. And that's something that I don't want to deal with, right? The whole purpose of using the equipment is to get this quicker analysis that's maybe a little bit more spot on. So my advice to you is that when you go to the rate on the instrument, you will want to convert that to 20 degrees instead of 10 degrees. And the reason is because this will shorten the 10-minute down to a 5-minute time. And this is much better. It's much more manageable to have a 5-minute analysis time than a 10-minute analysis time. You've just cut your workload in half when it's due to time. And when it comes to companies, time equals money, honey, right? So that's what we always want to put into our very forefront of our mind. Time is money. Money is how they pay me. And the quicker I can get this done, the more money they can make, and maybe the more money that they can give me as a result of it. So that's the purpose of the rate, the start, and the end temp. Then there's going to be a big green button down at the bottom, and it's going to say start. So you push the start button and it will begin the analysis. Now what's nice about this is that on the screen you will be able to see your capillary tubes filled with the solid, and you can kind of see that here in this picture. And then as the solid begins to melt and turn into a liquid, you will be able to see that on the screen as well. This is what the MP-50 actually sees at the same time. Now, the problem here is not loading the sample up the proper way. So there is an issue. You know, we talked about this capillary tube, and we talked about the capillary tube being filled at the bottom with some solid. When you take a look at this video screen, before you even begin, when you put your capillary tube in, you're going to see a well that the capillary tube will fit down inside of, and there's going to be 4 of them, because our machine can take 4 samples. Some machines take 6, but ours takes 4. And then inside of each well, there's going to be a big black dot. And this big black dot has to be covered up with your sample, or this machine does not understand that there's actually a sample in it. So when you put the capillary tube down into the machine, this capillary tube will go all the way to the bottom. Well, how much stuff is enough? That's always the question that people have. Well, when you put your solid down in here, you want to make sure that that solid covers up that black dot as fully as possible. If it doesn't cover the black dot, then that means you do not have enough sample in your capillary tube for the machine to do its job. Now, how does the machine do its job? It works on infrared light. So what happens is there is an IR beam that constantly shoots at that black dot. And as long as it can see through the dot, and as long as this infrared beam can come out the other end and see the detector, in the machine, its eyeball, then the machine, recognizes that there is no sample in that chamber at all. Once you put your solid sample down into the capillary well, then this does not work anymore. The IR beam cannot shoot through that black spot. And because it can't shoot the black spot, the detector says, oh, there's something there. And this is something that they want me to measure. So I'm going to take a closer look at that particular sample chamber, and I'm going to pay attention to when this solid will melt. So what happens is that over a course of time, as the sample begins to heat up, I start to see this sample liquefy. And when the sample liquefies, the IR beam can then shine through the liquid, and the detector is hit once again. And the detector says, oh, okay, I'm seeing the infrared beam now. That means there's nothing left in the sample chamber anymore. Everything has melted at this temperature. And it pegs that temperature and it reports that temperature out onto your screen. The MP-50 will give you a range. It will not settle with just one melting point. It will give you a range, and it will say it started at this and it ended at this. So maybe 138.9 and then it ended at 140.3. So it gives you a range of temperatures because it doesn't want to pinpoint it exactly on the spot. It does want to give you a window of opportunity to say, this is when it began to melt, this is when it fully melted, and there's about a degree or so difference that's in there that's a little wiggle room for us to play around with. So that's how the MP-50 works, and that's how it does its job. So don't ever say that I didn't invest into your future, because we did with this melting point system. We splurged a little bit and bought this melting point system, but again, these are the types of things that you're going to be seeing when you go out and work into the field. This does not have a printer hookup, so you will have to record the melting point on your own, and it also does not have a USB drive capability. So you can't save things directly on a USB drive. It takes a SD card, believe it or not. So we can save this information on an SD card and plug that up into a computer system. But otherwise, that's the only way that we can kind of print off this material for us. So this is a story with the MP-50 melting point system by Mettler Toledo. If you want to take a view of the Mettler Toledo website, by all means, type in MP-50 Mettler Toledo, Mettler Toledo, right up here at the very top. And then you will be able to visit their website and read more about this instrument. So yet again, another instrument that you can put on a resume that you can start setting yourself out from the crowd that has maybe just recently graduated from another trashy program, not like ours, right? Ours is kind of top-notch. That's what we're after. We're making top-notch graduates, and that's going to be you. So do a top-notch resume so that way you can represent the program like it should be represented. So with that said, have fun with the melting point system. You're going to do 2 by hand. You're going to be doing 2 by instrument. And then you're going to be averaging those samples together to report one number, and use that one number to determine what your unknown is. So good luck, have fun, and I'll see you in the lab.